Hey guys, welcome to 3.3 day 2 part 2 of the video. In this lesson we're going to go ahead and see some graphical representations and determine increasing, decreasing using these functions, these graphs. So the second example we have use the graph of f prime to, now I want you guys to notice, use the graph of f prime, graph of f prime. This is not the graph of f. This is not the graph of anything else. It's the graph of f prime. So one thing that I tell students to do is I always tell them to write big F primes all around. That way they know that they're dealing with the f prime, which is the derivative, not the function. And you'll see why in a bit. Letter A, identify the intervals at which the graph of f is increasing and decreasing. Now notice, the graph provided, what graph is this? It's the graph of f prime, but they want you to find the graph, the intervals at which f is increasing, not the derivative. So some of the biggest mistakes that my students will do is that they'll start telling me, well, this is the graph, it's increasing from here to here, and increasing from here to here, and decreasing from here to here. Well, that is true, but that's increasing of f prime, not f. As you guys know, f is the derivative. I'm sorry, f prime is the derivative of f. So you're looking at a derivative graph, not a function, not the original function graph. So here's what we have to do. We have to go back to our definitions. If f prime is greater than 0, f is increasing. If f prime is less than 0, f is decreasing. So how do we know if the derivative is positive or negative? Well, one thing that you guys should know already is that everything on top of the x-axis is positive and everything on the bottom of the x-axis is negative. So on what areas of the graph, on what intervals is the graph positive or above the x-axis? So we see that from here to here I have a positive slope, and from 4 to infinity I have positive slope because my derivative, my graph is a derivative graph. So I'm going to say f is increasing. On -3 to 1 and 4 to infinity, because f prime is positive. Whenever you provide the rationale, you always want to use what's given. Do not make any other assumptions. Do not say because f is increasing. No, you have to provide evidence given to you to justify your answer. F is decreasing on, well, this time we're going to be looking at the intervals of where the graph is negative here. So it's negative from from negative infinity to -3 we have a negative derivative, and from 1 to 4 we have a negative derivative. So f is decreasing from negative infinity to -3 and 1 to 4. And then justify your answer because f prime is negative. And you're done. Okay, so letter B. Estimate the values of x at which the graph attains a relative max and relative min. So let me go ahead and just erase all this. So when you have a maximum, a relative max occurs when f prime goes from positive to negative, and a relative min occurs when f prime goes from negative to positive. So here's what I'm going to do. We just realized that this part of the this part of the graph is negative, which means the derivative is negative. This part is positive. This part is positive. This part is negative. That part is negative. That part is positive. So this is the negative, negative. Let me do another color for positive. Positive, positive. How many times does the graph change from positive to negative and negative to positive? There is a total of 3 times. Now, this does not answer your question. Okay? The question says, tell me where the graph has a relative max and a relative min. So, if I look at the first part, if I want to find max, max occurs from positive to negative, so I'm going to go from here to here. We read the graph from left to right. It went from negative to positive, that's not a max. And then positive to negative, that is a max. So for letter B, relative max at x is equal to 1. And let's go ahead and do the minimums. Minimums means from negative to positive. So from negative to positive, here's 1. And from negative to positive, here's another. So I have 2 relative minimums. Relative min at x is equal to negative 3 and 4. And then we have to provide a rationale for these. So relative max, because, and I'm going to be very concise. Not only that, because I'm also running out of time. So because, now don't say because f has a maximum or any other reason. You have to provide reason from, you have to provide evidence of what's given to you. Relative max at x equals 1 because f prime, or you could even say the graph of f prime, but for because I want to be concise, I'm just going to put f prime because f prime changes from positive to negative. F prime changes from negative to positive. So that is the example 2 on your worksheet. Now, this is a very popular, very common type of problem that they'll give you. In my personal opinion, this is like level 1 in terms of rigor. There will be other problems that look crazy compared to this problem, but there seems to be all kinds of problems that look like this on your AP exam. So you may have a level 1 problem, you may have a higher level problem. I consider this to be like a baby problem, but I have seen these types of problems also on your exam. I'm not trying to tell you guys that your exam will be full of baby problems or hard problems, but definitely this is a very important concept for you guys to know. And in the next video, I'll finish up the last examples.